Hi, so today I'm going to first be talking about the first question in the Unit 4 assessment, which is sketch a function that has the following criteria. So the function I was given, I had the criteria where f of negative 4 is equal to 1. There are vertical asymptotes at x is equal to negative 6 and x is equal to negative 2. F prime of x is smaller than 0 from negative infinity to negative 6 and from negative 6 to negative 4. F prime of x is bigger than 0 on negative 4 to negative 2 and negative 2 to infinity. And the second derivative of f of x is smaller than 0 on negative infinity to negative 6 and negative 2 to infinity. And then the second derivative is also larger than 0 on negative 6, negative 2. And lastly, the limits from f of x as x approaches negative infinity and as x approaches infinity are both 0. So to start off, I put down some knowledge that I had prior. So I knew if the first derivative was going to be smaller than 0, that means that the original function would be decreasing, as well as the opposite, where if f prime of x is bigger than 0, that means the original equation would be increasing. Then when looking at the second derivative, I realized that if you are, I remembered that if it's f second prime of x is smaller than 0, that means that the original function has a concave down, and if it's bigger than 0, that means there's a concave up. So the first thing I did prior to graphing was I ended up putting in the points I knew. So I put in my vertical asymptotes at negative 2 and negative 6. I put in the point for negative 4 and 1, which is, you can see right here. And then what I did is, first I started off with the left side, so over here. So I knew when f prime of x was going to be smaller than 0 from negative infinity to negative 6, that means f of x is decreasing. So for f of x to be decreasing, and to also intertwine it with the fact that it's going to be a concave down from negative infinity to negative 6, which you can see from the f second prime of x, I end up resulting in this looking part of the function, because as you can see, it's decreasing and it's concave down. So that is for anything from negative infinity to negative 6. Now for in between negative 6 and negative 2, I knew that from negative 6, negative 2, f second prime of x is bigger than 0, which means that f of x is going to be concave up. And I also knew that it could not pass negative 6 or negative 2 as there were vertical asymptotes, and that there was a point at negative 4, 1. So what I did is I drew the point, and then since I knew it was a concave up, I graphed my parabola as given, because I knew it couldn't pass those 2 points, and I knew it was concave up from the point. Lastly, to speak about how I got this part of the graph, I knew from going back to the point for the parabola, I also knew that from negative 6 to negative 4, f prime of x was smaller than 0, which means it was decreasing, like the original function was decreasing. And then I also knew from negative 4 to negative 2, f prime of x was bigger than 0, which means it was increasing, which is how I also got the shape of the parabola and resulted in that. So anyway, going back to how I got this part of the function. So continuing back to the things I was given, I obviously knew there was a vertical asymptote at negative 2, so that part of the graph could not pass there. But I also knew from negative 2 to infinity, f prime of x was bigger than 0, and f second prime of x was smaller than 0. That means that the original function was increasing and a concave down. So the way I got that is how, as you can see, it's increasing coming from negative infinity vertically, and then it's a concave up, and then it continues to stay below the below 0 on the x-axis, because the limits for the function are 0 as x approaches negative infinity and x approaches infinity, which results in a graph like this.